All right, let's talk about AI. It's here, it's real, and it's changing everything. But here's the big question. Is your infrastructure actually ready for it? Today, we're going to break down the essential checklist to figure that out. So let's just dive right in with a core question. Is your infrastructure truly AI ready? Because AI isn't just some future tech hype anymore, right? It's being put to work everywhere. But, and this is a big but, there's a catch. And here it is. This is the problem. Most of the infrastructure out there today just wasn't built for the insane demands of AI. It creates this massive bottleneck that can stop your most brilliant innovations dead in their tracks. So what makes these AI workloads so different anyway? To really get this, we've got to understand the workloads themselves. See, AI isn't just one thing. It comes in a couple of very different flavors, and each one has its own very specific needs. On one hand, you've got training and fine-tuning. This is the heavy lifting, the serious number crunching. It's about building a model from the ground up or teaching an old model new tricks with mountains of data. This needs just brute force parallel computing and crazy high data throughput. But then on the other side of the coin, you have inferencing. This is the model out in the real world, doing its job, making predictions in real time. And here, the game completely changes. It's all about speed, super low latency, and being incredibly reliable. So you can see one size definitely doesn't fit all here. So the million-dollar question is, how do you build an infrastructure that can handle both? Well, that's exactly where this AI-ready checklist comes into play. You can think of it as your blueprint for success, a framework for a foundation that can handle whatever AI decides to throw at it. The checklist is really broken down into 4 key areas. First up, you need the right tools for the job. Special accelerators designed specifically for AI math. Second, you need lightning-fast memory and a network fabric to connect everything together. Third, you've got to have smart data pipelines to constantly feed the beast. And finally, number 4, you need secure and governed operations to keep the whole thing running like a well-oiled machine. Okay, let's dive into that first part, which is really the engine room of AI, the accelerators and the fast fabric that ties them all together. This is where all the raw power comes from. Now, what's really cool here is that it's not about just one type of chip anymore. Modern AI uses a whole team of specialists. You've got your standard CPUs acting as the conductor of the orchestra, handling all the logistics. Then you have the GPUs, the heavy lifters, providing that massive parallel power for training. After that, you get specialized chips like NPUs, neural processing units, that are purpose-built for super efficient inferencing. And you even have custom chips like FPGAs that you can program for very specific ultra-low latency jobs at the edge. It's all about using the right tool for the right task. But here's a little secret, something that really unlocks a ton of power. And it's not even hardware, it's low-precision math. Using formats like INT8 and FP8 lets these chips do calculations way, way faster and with less energy. It's basically a software trick that gives you this huge performance boost without having to add more power-hungry hardware. It really is the secret ingredient. But listen, all that processing power is completely useless if the chips are just sitting around waiting for data. That's where the network fabric comes in. It has to have ridiculous bandwidth. We're talking 100 gigabit Ethernet or even faster and almost zero latency. Why? Because every nanosecond your expensive accelerator is idle, you're just burning money. That is literally the most expensive bottleneck you can have in an AI system. So all of these powerful chips are super hungry, right? They need a constant stream of data. And that brings us to our next big point. You've got to have smart data pipelines. Honestly, the best way to think about this is like you're setting up a professional kitchen for your AI. Okay, first step in our kitchen is your hot tier. This is the food that's already on the plate, ready to be served immediately. It's your ultra-fast storage, like NVMe flash, holding the data your models need right now. Access has to be instantaneous, no waiting. Next, you've got the warm tier. Think of this as all your prepped ingredients sitting on the counter. They're not being served this second, but they're ready to be thrown in the pan and heated up in a flash. This is your mid-tier storage, balancing speed and cost for data you'll need pretty soon. And finally, the cold tier. This is your pantry. It's packed with all the stuff you'll need eventually, but not today. This is your cheap, long-term storage for historical data you rarely touch. The whole point of this tiered system is to make sure the right data is in the right place at the right time, so your models never, ever have to wait. Okay, so you've got the powerhouse hardware, you've got the super smart kitchen feeding it data, but you're not done yet. The job isn't over once a model is built and deployed. And that brings us to the last and maybe one of the most critical pieces of the puzzle, keeping your AI on the rails with MLOps and governance. MLOps. You probably hear this term a lot. It stands for machine learning operations, and it's basically everything that happens after your cool AI model goes live. It's the whole practice of making sure that model keeps running smoothly, securely, and efficiently over its entire lifetime. It's what turns a cool science project into a reliable business tool.
So we've gotten pretty technical, right? We've talked about chips and networks and data tiers, but let's zoom out for a second. Why does any of this actually matter? Because getting this checklist right isn't just about cool tech specs. It's about real, tangible business results.
It really all comes down to this. First, cost. It's simple. A well-designed, optimized system just runs cheaper. It uses fewer resources, which makes your AI deployments more affordable. Second, speed. You can innovate and get your ideas to market so much faster when your infrastructure isn't fighting you every step of the way. And finally, and this one's huge, trust. Good governance means your AI is secure, it's compliant, and it respects privacy. So in the end, building this foundation, it's about more than just being prepared for AI. It's about being able to move forward with absolute certainty. Because when all these pieces are in place, you're not just AI ready, you're AI confident. And you know what? That changes everything.